Our first video was on making good data tables. Now, let's make a good graph. The objective for this video is very simple. I want you to be able to say, I can make a good graph when we're done. Now, a good graph might mean different things to your math teacher or to your other science teachers, so I just want to be clear on the expectations for this class. Be sure to get your Unit 1 packet out and take notes in your Unit 1 packet or on a separate sheet of paper, because you'll be able to use these notes on the quiz at the end, and I'll stamp your notes for points at the end of the unit. We already looked at data tables as a really good way to help keep data organized. Now, the good thing about a graph is that a graph you can see data points very easily and see relationships in data and trends in data very quickly. So here's an example where test scores are graphed versus hours of study, and what you can see is that there's a general trend towards the more you study, the higher your test scores. Let's see how to make a good graph. So here's an example of a data table that I want to use. Now what I'm hoping to show you from this is how confusing a data table can be if you don't follow the rules that we had in our last video. Can you remember the 3 rules for a good data table? Remember, a good data table is neat, and I think this data table follows that criteria. It has a scientific title, and it has column headers with units. The fact that this doesn't have column headers or a title makes this really confusing. So let's add that to this data table right away. So the data that we're looking at is the temperature of my tea. I really like to drink tea, and sometimes you'll see me with my green thermos drinking tea out of it. So what this is showing is the temperature of my tea in degrees Celsius compared to time. And we want to make sure to graph this very, very neatly. So let's go over the rules of a good graph. Just like a good data table, a good graph is neat. So what you want to do when you draw a good graph is make sure that you have a ruler. So most of the time, the graph paper is going to be given to you, but if it's not, use a ruler and make this graph neat. Another criteria is that a good graph is big. If you're drawing a graph, make sure that the graph fills up at least half the page, or if you're given a piece of graph paper, make sure that your data fills up at least half of the graph paper. So you want to spread it out as much as you can. A good graph has labeled axes. So you have the y-axis and the x-axis. And what you should make sure that you label the axes with are the variable, such as time or temperature, and the units. So let's label these. Now remember, a graph has a y-axis and an x-axis. And a good mnemonic for the y-axis, in case you're confused, is that if you had to draw a graph, the y-axis is like a big letter Y. So let's label these up. On this graph, we want to put temperature on the y-axis. So put the variable, temperature, and put the units in degrees Celsius. On the x-axis, we're going to put time, the variable, and the units, minutes. Now it looks kind of sloppy because I'm doing this on my iPad, but let's make it a little bit more formal here. This didn't transfer over very well, but you get the idea. It looks a little bit neater typed, and if this was a real graph on paper, I'd be sure to use my best handwriting. The next thing that we want to have for our good graph is, just like our good data table, we want to make sure that our graph has a scientific title. Now the easiest way you can put a title on here is you take what's on the y-axis, which is temperature, and you would say temperature versus what's on the x-axis, time, but then give a little bit bigger of a description, a little bit better of a description. Temperature versus time of what? And in this case, it's Dr. Wallace's tea. So we're not looking for some hugely complicated title here, just something that makes sense, and it's not cutesy. Now the next thing that we want to do is we want to make sure that our graph has a good scale. And what I mean by that is that each box on the graph is going to mean the same amount. And this is going to take a little bit of planning. And one of the first steps you're going to have to do after you set this up is you're going to have to count the boxes. So on the temperature side, let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So there are 21 boxes along the y-axis for temperature. And we need to cover 80 degrees. So a good scale to use would be to make each box worth 4. And we can go along and we can label every other box 0. Then the first box would be 4. Then we have 8. Then 12. Then 16. Then 24 up here. Then 32. 40. 48. 56. 64. 72. And 80. And that fit really nice. Now we want to count the x-axis. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 boxes. And we need to be able to fit 33 minutes. So one way you could do this is you could take your 33 minutes and divide it by 10, and that'll tell you about how much each box has to be worth. And that would be 3.3. So I'm going to round up to 4. So each of these boxes on the x-axis has to be worth 4. So what I'm going to do again is label every other box, starting at 0, and then going 8, 16, 24, 32, and 40. And that way our data is going to be nice and spread out, and each box means the same amount. One common mistake that I've seen with young physicists is that sometimes people will just say, okay, the first slot is 0, then I'm going to make this 1, then I'm going to make this 8, then I'm going to make this 13, and that's an illegal move. So be sure not to do that. Now let's make this graph nice and neat and put our data on here. So the last thing that we want to do is make sure that our data points are protected. And what that means is to draw your data points really big, as maybe like really big dots, or you can put them in a shape, like a triangle or a square, or even like a circle around your dot, something to where they're not going to get lost. Because one thing that we're going to do next is draw a trend line, and we don't want any of your data points to be hidden. So up until now, a lot of people when they make graphs, they're really eager to put their data points on. But up until now, all we've been doing is planning to make sure that our graph is going to look really nice and make our trends kind of pop out. And now we're actually putting in the data points. So let's go ahead and do that. At time 0, the temperature of the tea is 80 minutes. 1 minute later, the temperature drops down to 75 degrees, which is about here. At 8 minutes, the temperature is 70 degrees. – 13 minutes, 60 degrees. 20 minutes, 16 degrees. 20 minutes, 60 degrees. 26 minutes, 55 degrees. And 33 minutes, 45 degrees. And you can see this trend nice and easy on the graph compared to the data table. So, remember the good qualities of our graph. The next thing you're going to do is draw a graph for your Penny Lab. So, a good graph is neat. A good graph is big and takes up most of the space. A good graph has labeled axes, where the axes are labeled with the variable and the units. A good graph has a scientific title, with y versus x being the minimum title that you'd want. A good graph has a good scale. And finally, a good graph has protected data points. I hope this was helpful, because we're going to be making a lot of graphs in this class.